Hello everyone. Today we'll be considering or discussing R and S configuration of 1 and 2 stereogenic centers using Fisher projection. Fisher projection is also an alternative method of determining configuration of molecules, especially when there are one or more stereogenic centers. For example, let us consider 2-chloropropane-1-or. Let us use Fisher projection to determine the R and S configuration of this compound. The first thing we have to do is to draw the structure of 2-chloropropane-1-or. The next step is to convert the structure of the molecule to Fisher projection. The third step is to convert the substituent, the vertical substituent in the chiral center, to dash, while the horizontal substituent attached to the chiral center is converted to wedge. In the first step, we change one of the wedge and one of the dash to a straight line. It doesn't matter which one you change, any one you change, you will still arrive at the right answer. In step 5, that is where we carry our first interchange. We carried out this first interchange because the hydrogen, which is the element with the least priority, is in straight bond. It is not in dash, and we have to bring the hydrogen, which is the element with the least priority, in dash. That is why we interchanged hydrogen and the methyl group. Since we changed the position of substituent in step 4 to get the atom with the least priority in dash, we have to carry out another interchange in step 6 to get the original configuration of the compound, since we have already moved the position of substituent from step 4 to step 5. In the choice of substituents to be moved, we can move either the chlorine, the methyl, or the alcohol substituent, but we don't need to move the position of the element with the least priority, which is hydrogen. So I chose to move again the methyl group and the alcohol group to get this position of substituent in step 6. Having gotten the position of substituent in step 6, then we can now take the correct configuration of the compound. Let us consider compounds with 2 stereogenic centers. We can number the stereogenic centers. We can call here 2 and we can call here 3. The first step will be to focus on the configuration on the serial center 2 while condensing the stereogenic center 3. From step 1, we are going to convert the vertical substituents to dash, while the horizontal substituents are converted to wedge, as we have earlier discussed before. In the third step, one of the wedges and one of the bond in wedges and one of the bonds in dash is converted to a straight bond. Having gotten our 3D structure of the compound, we can now assign configuration based on the atomic numbers. In step 4, we carry out our first interchange by bringing down the element with the least priority to the bottom, which is the bond with dash. Since we have changed the position of molecule in step 3 to get the compound with the least priority in dash, we have to carry out another interchange, which is the second interchange, by either changing any of the substituents except the one with the least priority. So I chose to change the position of the substituents of the carboxylic group and the alcohol in the second interchange to get the compound in step 5. This means that the chiral center 2 has 2 arrow configuration. Let us consider the chiral center 3. We made the compound to look like one stereogenic center by condensing the chiral center 2 in order to determine the configuration at the chiral center 3. As usual, in the first step, we convert the substituent in the vertical part of the chiral center to dash, while the horizontal substituents are converted to wedge. In the second step, we changed one of the bonds in dash and one of the bonds in wedge to a straight bond. In step 3, we carry out our first interchange by bringing down the element with the least priority, which is hydrogen, in dash. We did that by interchanging the hydrogen with the alcohol functionality. to get the compound in step 3. Since we interchanged the position of substituent in step 3 to bring down the element with the least priority to the bond in dash, we have to carry out another interchange to get the original configuration of the molecule in the second interchange. So in the second interchange, you can move the position of any molecule without touching the position of the substituent in dash, which is hydrogen. So I chose to move the positions of the substituent in a straight bond, which are the alcohol and the substituent containing the carboxylic functionality, to get the molecule in step 4. Since I have my step 4, then I can confidently assign the configuration of this substituent at the chiral center 3, which will give us the actual configuration of the substituent in chiral center 3. So in step 4, I have the compound with the least priority in dash, and I have carried out the second interchange to get the original configuration of the molecule. Then I will assign the configuration at the chiral center 3, starting from the substituent with the highest priority. As earlier stated, the position of the substituent with the least priority is insignificant. So going from the substituent with the highest priority, I will go from 1 to 2 and from 2 to 3, which will give us the S configuration in the chiral center 3. So in summary, the configuration of this molecule with 2 stereogenic centers in position 2 and in position 3 are 2R and 3S. Thank you so much for taking time to watch my video to the end. Please like, subscribe and share. If you have any question, any suggestion, any contribution, please you can leave that in the comment section.